Okay, now we're going to look at some pseudocode for the force calculation just to get you started. I think probably looks about like you would imagine, but there's a simple recursive implementation that's worthwhile to go over. So I'll make sure you have this in the updated version of the notes, and I'll make a few points about it. So let me share the screen. Okay, so the goal here, remember, is for each particle, you're going to compute the net force on it by all of the other either particles or centers of mass associated with clusters of particles. Okay, so that's what the outer loop is for each particle. So let's just look at what you're going to do for one particle, the first one, and it's the same for all n of the particles. So we're going to call this recursive function tree force on root. And the way tree force works is if the node that you are calling it on, it's going to be called recursively. So it won't just be called with root. But if the node you're calling it on contains just one particle, then you're just going to compute the force directly as in homework 2. Okay, so if root literally had 2 particles in it, one other one, then you would just do this and you'd be done. Okay, well, since it isn't, it have many more particles, then you're going to have some kind of criteria to know if you can do the center of mass or total mass approximation. It's usually based off of, as I said, the distance and maybe the size of the node in physical space. So that ratio is less than some threshold, let's say. We won't worry about the detail right now. It's not really important ever for us. But we're going to compute using the center of mass. Okay, so if our approximation is okay, we are just going to use the center of mass. It's not a leaf node, right? But we're going to use the center of mass associated with that node, which contains subnodes, which have particles in them, right? If it's not okay, though, then we're going to have to look inside the node. So we're going to loop over all the children of the node, and we're going to add up the sum of the forces executed by each of those children nodes. So we're going to call tree force again recursively. Let's say that each of those are just leaf nodes with one particle. Then it would just for each of them call the direct force calculation, sum them all up, and then the force on that particle would be the sum of the forces of the subnodes. And this is true recursively. So it will cover all possible particles by the time it's done executing, right? So if furthermore you go into the children and each of them has many particles in it, it will then call it recursively and it will take care of everything. It will take care of the cases that you can use the center mass approximation, and it will add up all the way at the leaf nodes, things that you have to represent as point particles because they don't meet this criterion. Okay, so this is very elegant, just a few lines of code. I think it exactly matches what I articulated on the PowerPoint slide. And I won't show you the code that I have for doing this because I think it'll be a good exercise to try to get it to work. And you just let me know if you're having any problems. And the only thing other than this and what I showed you is just to do the center of mass calculations. Okay, the center of mass calculations are just, since all masses are one, we're not distinguishing masses, we're thinking of these as particles and not bodies, then the center of mass for any cluster of particles is just going to be their average position, which is just the average of their x component of their position and the average of the y component of the position, forming a point, an average point in space. Okay. All right, so I'll do one more segment where I talk about the model 1 and model 2 trees, but that won't be relevant for doing the homework problem. It'll be something that we need to revisit later on, either in the quiz or the midterm or a piece of another assignment.